Hey guys, welcome to the channel vibgyoroftalents. So in today's video, let's get started with this chapter, Trigonometry. So it is the chapter 8 of class 10 NCERT from the mathematics subject. So this is going to be officially the part 1 of this particular chapter, but I've also made a previous video about trigonometry only. In that video, I've explained all the concepts and all the things that have been coming out from the formulas and all that we are going to see before. So that is all related about concept, but actually not necessary for the exam point of view. But if you want to learn something new, I would 100% recommend you to watch that, and you will learn something new after watching that, and I promise you. But if you don't want to learn anything extra and you just want to get full marks in an examination, so then this is the perfect video that you are going to watch now. This video is going to be really important in terms of exams, so I would recommend you to watch this. So as I have already said you in the previous video that we are going to be doing all this series of this particular chapter trigonometry itself, and we are going to do all the exercise problems too together. Alright, so let's get started with today's topic. So in today's video, we are going to particularly concentrate on this topic named trigonometric ratios. So by looking at the name, it looks complicated, but it's going to be really simple, and I promise you that by the end of this video, you will be absolutely sure on what is trigonometric ratios and how to solve many problems regarding it. So first of all, to get a good knowledge and start with this trigonometric ratios, let's quickly take a right angle triangle. So let's take a right angle triangle named ABC. So I have drawn it right here, as you can see. So first of all, in here that if you see, the angle CAB is an acute angle. So the trigonometry that we are going to learn in this year of class 10 is going to be only based on acute angles. So the other angles we are going to learn in the future. So for class 10, all the angles that you see, one will be 90 degrees and the other one would be definitely, one will be definitely an acute angle. So in here we have angle CAB as an acute angle. Alright, and then if we note the position of the side BC with respect to the angle A, so it faces towards angle A, right? So we call it the side opposite to angle A. So BC is called the side opposite to angle A. As you can see, this angle A is quite opposite to the side BC. As you can, if you look at it also, you would definitely tell that BC would be just opposite to that of angle A. They're standing opposite to each other. And if you guys remember, in a right angle triangle, we had something known as hypotenuse and base. So the hypotenuse wouldn't change according to angle. Always and always the hypotenuse will be hypotenuse. So in here, in this right angle triangle, we have something known as hypotenuse, which is the length of AC. And also remember, hypotenuse is the longest side of a particular right angle triangle. For every right angle triangle, hypotenuse would be the largest side. So how to figure out which side is going to be hypotenuse? So this is going to be a simple trick. So you see 90 degrees at angle B, right? So it is just opposite to that of hypotenuse. Always remember, the side which is just opposite to angle B would be hypotenuse. As we said, the side opposite to angle A in here is BC, but this is going to be not same for everything because angle A may change from one picture to another picture of triangle. But this thing, that angle, the right angle triangle that we have is always opposite to that of hypotenuse. Don't remember the name of angles like angle A or angle B. Remember that the 90 degrees angle is opposite to that of hypotenuse. That's it. And we have one more side left. We have got one side as hypotenuse and we have said the other side is opposite side. So we have one more side missing. What is it? AB. So as we have related BC as the side opposite to angle A, let's also relate this left on side with angle A. So if we relate AB also with angle A, we would get that AB is the side adjacent to angle A because they are both sticking, they are both beside each other. So we can say that AB is the side adjacent to angle A. So we are naming all the sides of this triangle in accordance with angle A. So if you do that, we'll get like this. The CB will be the side opposite to angle A, AB will be the side adjacent to angle A, and I have said you, hypotenuse in every and each triangle will always be same, no change according to angles. Cool. But we should also know that the position of the signs may change when we consider angle C instead of angle A. Right? If you keep changing the angles, we might be getting different sides like before. As I've said you, hypotenuse will be constant and these sides will be changing according to the angle that we prefer, in which we have to take accordance to. For example, if we take angle C instead of angle A, everything would get changed. So AB would become the side opposite and CB would become the adjacent side. So we have studied the concept of ratio in our earlier classes too, but we can define certain ratios involving the sides of a right triangle, and those are called nothing but the trigonometric ratios. So if we try to actually write the trigonometric ratios of the angle A in this particular right angle triangle ABC itself, we are going to get actually 6 ratios. So let's look at them. So these are named differently according to each one of them. The first one that is going to be is this sine. The sine of angle A would be the side opposite to angle A by hypotenuse. So in this particular figure, what is the side opposite to angle A? We know that it's BC and hypotenuse is AC. So the sine of angle A would be BC by AC. So remember that sine of angle A is, or simply remember, sine theta would be equal to, if we take theta as some particular angle, so sine theta would be equal to side opposite by hypotenuse. Alright? And then if we consider the next ratio that we have, it is going to be cosine. So cosine of angle A would be equal to side adjacent to angle A divided by hypotenuse. So the side adjacent to angle A that we have here is AB and the hypotenuse is AC. So the ratio is going to be AB by AC. So here also, if we consider the angle to be theta, then cosine of theta would be equal to adjacent side by hypotenuse. So you can remember like that. And then we have tangent of angle A. So the tangent of angle A would be side opposite to angle A divided by side adjacent to angle A, which is equal to BC by AB. So these are the first set of ratios. Remember the trigonometric ratios in form of 2 sets. So we can call this the first set. So you'll know the reason why we are dividing into 2 sets. So this will be first set. Let's look at the second set of ratios. So in here we have the first ratio as cosecant of angle A. So it is nothing but 1 by sine of angle A. So what is become? So we know that sine of angle A is nothing but side opposite divided by hypotenuse. So if we try to reverse it, it is going to be reciprocal of that. So cosecant of angle A would be equal to hypotenuse divided by side opposite to angle A. So in here also just the ratios are getting switched. So we are going to get the alphabetical ratio as AC by BC in that triangle. And then let's look at secant theta. So even the secant theta is actually the reciprocal of something. So what is it something? It is the reciprocal of this cosine theta. So I am telling theta, that is, it can be any angle, but in here we are considering the angle A. So it is going to be 1 by cosine of angle A. So if you remember, the ratio of cosine of angle A was side adjacent to angle A divided by hypotenuse, but as we have taken the reciprocal of it as secant, so the ratio would be hypotenuse divided by side adjacent to angle A. So here also the ratios are being switched, so the alphabetical ratio would be AC by BC in this triangle. And then we have the cotangent. So even this cotangent is the reciprocal of tangent, that is, we have the tangent value as side opposite to angle A divided by side adjacent to angle A. The same way, if you do the reciprocal, we are going to get it as side adjacent to angle A divided by side opposite to angle A, which will be equal to AB by BC. So these were the full form of these, but for simplicity's sake, we can even shorten them. So the ratios defined before were abbreviated as sin theta, cos theta, tan theta, cosec theta, sec theta and cot theta respectively. So here we have used A, so it is going to be sin A, cos A, tan A, cosec A, sec A and cot A respectively. So we have to note that in here the ratios cosec A, sec A and cot A are respectively the reciprocals of the ratios sin A, cos A and tan A, all respectively. Alright? And if you have observed something else, we can find that tan A. What is tan A? What was tan A? It was BC by AB. So what we got BC as, we can write BC as BC by AC, and we can also write AB as AB by AC. So BC by AC divided by AB by AC. So what was BC by AC? It was nothing but sin A. And what was AB by AC? It was cos A. So what is sin A by cos A? It is tan A. So you can remember it also as sin A by cos A. And as cot A is the reciprocal of tan A, we can say that cot A is equal to cos A divided by sin A. Interesting, right? And also the trigonometric ratios of an acute angle in a right triangle actually expresses the relationship between the angle and the length of its side. So we have been given an angle, and with the help of that we found out the sides. Alright, so your brain might be actually heating up by looking at all these new things. But I am going to tell you a very simple way on how to remember the trigonometric ratios very easily. Alright, so basically we have 6 trigonometric ratios. Remember them in short form, no need of full form itself. So one is sine, the second one is cos, third is tan, and the reciprocal of sine would be sec, the reciprocal of cos would be cosec, and the reciprocal of tan would be cot. So remember these 6 ratios like this. So now if you want to get out the sides from the first sine, the trigonometric ratio to the sine, so sine theta is equal to opposite side by hypotenuse. So pick out the first letter in all the 3. So you can remember it as SOH. So if you hear the word SOH, you should simply remember sine theta is equal to opposite side by hypotenuse. It will be easier way for you. And then cos theta is equal to adjacent side by hypotenuse. And again, if you pick out the first letters in all 3, this is going to be CAH. So remember it as CAH. If you remember CAH, then you will be easily getting out cos theta is equal to adjacent side by hypotenuse. And again with tan theta, remember it as TOA, as tan theta is equal to opposite side by adjacent side. And guys, don't get confused between thetas and angle A that we have used before. Angle A was taken as before because in the triangle they said to use that angle particularly. But if you take the value of theta, if you substitute any angle in place of theta, it would satisfy. So consider it making habituated to learn it as theta because it's going to be more easier. And theta would satisfy for any triangle, alright? And no need to actually remember the other things which are cosec, sec and cot theta, because cosec theta is nothing but 1 by sin theta, and sec theta is equal to 1 by cos theta, and cot theta is equal to 1 by tan theta. So if you just remember SOH, CAH and TOA, it's going to be very simple for you. That's it. So as we have learned something new right now, so let's just try how much have we known from these that we have learned now. Shall we? Alright, so let's go ahead and quickly look at a question. So in here we have given the value of tan A is equal to 4 by 3, and we have to find the other trigonometric ratios of this angle A. So I'll be explaining you step by step how to do these types of problems. So please do follow me along with me. You can also do these particular problems. Alright, so let's get a solution and look how to do. So first of all, the first step I would recommend you to do is to simply draw a rough diagram of this particular things that have been given. So the trigonometric ratios can only be taken in a right triangle. So let's just quickly draw a right triangle. So we have taken this right triangle ABC, and if you can see, the right angle is at the point B. Angle B is equal to 90 degrees. Alright, we are done with the rough diagram. So the next step is to find out what is being actually given to us from the question. So we have been only given one value. What is that? Tan A is equal to 4 by 3. We have not been given anything else, and we have to find the other trigonometric ratios on our own. Alright, so if we have been given the value of tan A is equal to 4 by 3, so let's just quickly write that tan A is equal to 4 by 3. And then, do you remember the 3 codes I have told you? So what is it for tan? Oh yeah, the code for tan is TOA, which is nothing but tan theta is equal to opposite side by adjacent side. Look, if you remember it as TOA, you're going to simply get it very quickly, right? So tan theta is equal to opposite side by adjacent side. So it's going to be simply become 4 by 3 is equal to opposite side by adjacent side. So what do you get from that? What do you infer from that? You can simply say that the opposite side length will be 4 and the adjacent side's length will be 3. Simple. So we have got the opposite side and adjacent side now. Cool. But wait. what is going to be opposite side and which side is going to be adjacent side? We have been given the angle that we should consider in this particular triangle, which is angle A. So the angle A is right there. So let's just update our triangle which was drawn in the beginning, as we have got the sides opposite side and adjacent side. So as you keep getting the values, you should be updating the triangle so that it's going to be easier for you to solve the question. So as the angle A is our accordance angle, so what would be the opposite side? So the opposite side would be BC and the adjacent side would be AB. So the value of AB would be 3, the value of CB is going to be 4. So we have updated our triangle also. And then, if you guys remember, we used to use the Pythagoras theorem in the previous classes. So this Pythagoras theorem is going to be very useful in this particular chapter of trigonometry here. So what do we know from the Pythagoras theorem? So our friend Pythagoras told that AB square plus BC square is equal to AC square. So the height square plus base square is going to be the hypotenuse square. So in here, AC is our hypotenuse, AB is our base, and CB is our height. So let's just substitute the values, because we already know the values of AB and BC, so that we'll get the value of AC also. So we are going to get all the sides of the triangle, then it would be very easy to find out the ratios of the triangle. So the value of AB we have as 3, so it's going to be 3 square, and value of BC is 4, so it's going to be 4 square. So 3 square plus 4 square is equal to AC square. And then we know the values of 3 square. So, and also 4 square. And also guys, I recommend you to learn all the squares till 25 and all the cubes up to 15. So it's going to be super easy to just quickly solve all these types of problems in just few seconds if we try to learn all those cubes and squares. So I will give a sheet in which the squares till 25 and the cubes till 15 will be given. You can just every day look at it for just 2 minutes, and by nearly 30 days you'll be able to completely learn that entire thing. And I would also recommend you, if you use a mobile or a laptop frequently, then if you make it a wallpaper of that, you can remember it more easily, as you'll be seeing frequently. Every time you watch, you will read something and then it will get stuck into your brain. So that's going to be an easy trick to learn. If we just know the squares, we can also know the roots of them too. So it's going to be super useful, right? So let's just continue solving our problem. 3 square plus 4 square is equal to AC square. So 3 square is 9 and 4 square is 16. So 9 plus 16 is equal to AC square. So 9 plus 16 would be just 25. So AC square is equal to 25. And if we take root on both sides, we are going to get AC is equal to root 25. Because on the AC side, the square and root gets cancelled. On the 25 side, we are going to just be left with root 25. So we know that 5 square is 25. So AC's length would just be 5. So we have also got the length of AC. Let's just update our triangle. So we have written the length of AC as 5. Okay, so now if you observe, we have got each and every side's length. So it's going to be super easy to also find out all the trigonometric ratios of this particular triangle, right? Okay, so let's start finding trigonometric ratios. First of all, what is sine theta? Sine theta is equal to opposite side by hypotenuse. We know our code. What is the code for sine theta? It's SOH. So by SOH, we know sine theta is equal to opposite side by hypotenuse. So our theta is actually angle A here. So what is the opposite side to this particular angle A? It's BC. So it's going to be BC. And what is the hypotenuse? AC. So it's going to be BC by AC. So the length of BC is 4 and the length of AC is 5. So the value of sine theta, the ratio of sine theta or sine A would be 4 by 5. And then let's look at the next trigonometric ratio. The next trigonometric ratio's code is CAH. Oh yeah, CAH is cos theta is equal to adjacent side by hypotenuse. And what is adjacent side to angle A? It's AB. So the ratio would become 3 by 5. 5 is the hypotenuse of AC. And then we need one more ratio in our first set. But actually you don't need to even write it, because that's what we were given in the question. Tan A is equal to 4 by 3. We already know that, so we don't need to write that. Let's skip that. So let's move to the second set of ratios that we have. So what is the first ratio that we have? Yes, it is cosecant theta or cosec theta. So cosec theta is equal to 1 by sine theta. We know that. So what we have already got the value of sine theta. So it is going to be 1 by 4 by 5. So the reciprocal of sine theta would be just 5 by 4. So the value of cosec theta is 5 by 4. Simple, right? If you just know all those codes, you're going to just make it very quickly. And then the next ratio we have is secant theta or sec theta. So sec theta is equal to 1 by cos theta. We know the value of cos theta, which is 3 by 5. So the reciprocal of 3 by 5 is going to be 1 of 3 by 5. So the value of secant theta would just be 5 by 3, the reverse of cos theta. Simple. And then the last ratio that we have is cot theta. So cot theta is equal to 1 by tan theta. We know the value of tan theta is 4 by 3. So it's going to be 1 by 4 by 3. So if you take the reciprocal of it, it's going to become cot theta is equal to 3 by 4. So that's it. Are we leaving anything else? Oh no, that's it. So all the trigonometric ratios would become sin theta is equal to 4 by 5, cos theta is equal to 3 by 5, cosec theta is equal to 5 by 4, sec theta is equal to 5 by 3, cot theta is equal to 3 by 4. So that is it. We are done with the question. It was super easy, right? So in the same flow, let's try to look at another interesting question, and we are going to do super easily just as the previous question. This question is also be based on our concept trigonometric ratios. So let's have a look at the question. So the question that we have been given is that if angle B and angle Q are acute angles such that sin B is equal to sin Q, then we have to prove that angle B is equal to angle Q. So this is actually proof here, and remember in trigonometry you're going to be seeing many proofs like this, not similar to this, but they're going to be super different from each other. So you should concentrate and look more at proofs, as they are going to be a little more difficult than actually doing our questions, which you should do in our previous classes. So let's get started. So first of all, I've said you what is your first step to do in any type of question. The first step is to draw two triangles in this trigonometry chapter. So let us consider two right triangles ABC and PQR. And here we have been given that sin B is equal to sin Q. So let's also just write that. So if you take a look at the first triangle ABC, you get to know that AC is the side opposite to angle B, and AB is actually the hypotenuse. So we can get the value of sin B itself, because sin theta is actually equal to opposite side by hypotenuse. So we are going to get the value of sin B from our code, which is SOH. So sin theta is equal to opposite side by hypotenuse. So we are going to get the value of sin B as AC by AB. In the same way, if you look at the second triangle also, which is PQR, in here the side opposite to angle Q is PR, the hypotenuse would be PQ. So sin Q would be equal to PR by PQ. Alright, so we have got the values of sin B and sin Q. So actually these both are equal. So we can write it as AC by AB is equal to PR by PQ, because in the question itself we have been given that sin B is equal to sin Q. So and then let's just try to cross multiply AC by AB is equal to PR by PQ, and we are going to just cross multiply AB and PR. So we are going to pull that PR down to AC, and we are going to pull up that AB above PQ. So it's going to be AC by PR is equal to AB by PQ. And we are going to say this entire thing is equal to K. So it's just a constant that we are taking here, and you'll get to know the reason why we have taken it as K. So you can take any constant. So in here we are taking K. So AC by PR is equal to AB by PQ is equal to K, and so let's mark this as 1. Equation number 1. Alright. Now let's again bring our friend Pythagoras and ask him the Pythagoras theorem. So now we can actually use the Pythagoras theorem, and we know that BC will be equal to root of AB square minus AC square. If you look at the triangle ABC, so BC would be the base. AB is the hypotenuse, so if we subtract hypotenuse minus the height, we are going to get the base. Alright, again look at the second triangle that we have, which is PQR. In the same way, PQ is also the hypotenuse there, and we are trying to find out the base that we have. So QR would be equal to root of PQ square minus PR square, which is just by this Pythagoras theorem. And if we actually try to divide PC by QR, we are going to get it as root of AB square minus AC square divided by root of PQ square minus PR square. And from our first equation, we know that AB by PQ is equal to K. So in place of AB square, we can substitute K square is equal to PQ square just by cross multiplying. And in the same way, AC also, we know that AC by PR is equal to K. So that's from the first equation again. So we can also cross multiply that and we can write it as K square PR square. Alright. So it's going to become root of K square PQ square minus KR square PR square divided by root of PQ square minus PR square. Alright. And then we can actually take K square as common in the first numerator that we have. So if we try to take it common and if we actually try to bring it out of the root, before it was K square. So if it comes out, it's going to become K. So finally it would be K root of PQ square minus PR square divided by root of PQ square minus PR square. And now we can actually cancel root of PQ square and minus PR square. We can cancel both the numerator and the denominator, and then finally we'll get the value as K. So what is the value of K? So what is K? The value of K is nothing but BC by QR is K. So we have got the value of BC by QR as K, and we are going to name it as 2. This is going to be our equation 2. Now what do we try to get out from this 1 and 2? So from 1 and 2 we have AC by PR is equal to AB by PQ is equal to BC by QR. Because K, we have got the value of K also as BC by QR. We have already known from the first equation that K is equal to AC by PR is equal to AB by PQ. And now if we substitute the value of K with QR, so we are going to get it as AC by PR is equal to AB by PQ is equal to BC by QR. And now all the three sides in both the triangles are equal. So from SSS similarity of triangles, we get to know that two triangles are equal or similar when the corresponding sides of two triangles are proportional. So this is the property that we have regarding similarity, SSS similarity of triangle. So from that we can say that triangle ACB is similar to triangle PRQ. So if they are similar, we can say that the angles are equal. So the angle B would be equal to angle Q. So that's what we were asked in the question. We were asked to prove that angle B is equal to angle Q. So it is a little bit complex, so don't worry if you didn't understand it once. Just go back to a few seconds and again clear from the beginning of the question and watch it again. No harm, but you should understand this very importantly. Alright, so by now you must be tired, and even I am tired. And thanks a lot for watching, guys. And please do follow us on Discord, Twitter and Instagram. And don't forget to subscribe to our channel and hit the bell icon so that you'll get the notifications of all the latest videos of our channel. And we are continuing with this series Trigonometry, so it's going to be very useful for you. And in the next video of this series, we are going to be looking at the exercise 8.1. So let's together solve this exercise 8.1. So thank you once again, and please do subscribe, and if you like this video, leave a like down below. If you have any doubts, you can ask me in the comments or also mail me at vibgyoroftalents@gmail.com.